Handwritten notes for the following lectures are given in the description box. These are in the exam point of view. Lines from K. Tripathi are simplified and given for you to write in your exams. Everyone, welcome to Docsiverse. Today we will be dividing into an essential topic in pharmacology, biotransformation, which comes under metabolism in pharmacokinetics. First, we will see what is metabolism. Metabolism is nothing but it's just a biochemical process which happens in our body to transform the drugs, either to eliminate them or activate them for any intended effect. The basic mechanism behind biotransformation is nothing but the conversion of non-polar, that is lipid soluble, into polar, that is water soluble. What does lipid soluble drugs do? They can easily pass into the cell membranes and they can be easily absorbed into the cells. Whereas what does water soluble drugs do? Can be easily excreted, as they can easily get inside the blood and they will be excreted via kidneys. Where do all the drugs get metabolized in our body? The primary site for the drug metabolism in our body is liver, and then comes kidney, intestine, lungs and everything. So biotransformation can be divided into two, that is phase 1 and phase 2 reactions. Phase 2 reactions is nothing but non-synthetic, whereas phase 2 reaction is synthetic reaction. You can also call the non-synthetic reaction as functionalization, whereas you can call the phase 2 as conjugation. Non-synthetic reaction is nothing but, as the name says, functionalization. You're just adding functional groups. It can be OH, COOH or anything. Any functional groups can be added in phase 1 reaction. We can remember by the mnemonic OR, O or CHAAD. O for oxidation, R for reduction, C for cyclization, H for hydrolysis, A for aliphatic hydroxylation, A for another A for aromatic hydroxylation, and D for deamination. You can remember the phase 2 reactions as GAMS, that is GGAMS. Glucuronidation, glycination, acetylation, methylation and sulfonation. In GAMS, that is the synthetic reactions, only glucuronide conjugation is microsomal, whereas the other four are non-microsomal. Oxidation is basically addition of oxygen or removal of hydrogen. Basics. What are the various oxidative reactions? It includes hydroxylation, which is addition of OH, and oxygenation, which is addition of oxygen at carbon, nitrogen and sulfur atoms. It also includes oxidative deamination and oxidative acetylation. It also includes oxidative deacetylation, which is removal of acetyl group. So, who carries all these oxidative reactions? These oxidative reactions are carried out mostly by group of oxygenases, which is a monooxygenases in the liver. Most of these oxidative reactions are carried out by group of monooxygenases in the liver. So, who do carry out these oxidative reactions? They are monooxygenases. So what do you mean by the term monooxygenases? These are nothing but these are the ones who incorporate one single atom of oxygen into the substrate. Most commonly known monooxygenases are P450 hemoprotein, NADH and cytochrome P450. So in this, the cytochrome P450 is very, very important because it has multiple isoenzymes which has different in their affinity for various substrates. What do you mean by the term cytochrome P450? CYP450. C stands for cytochrome, P stands for pigment, and 450 is the nanometer, which is the wavelength of the light. So now we're going to see the major drugs which metabolizes the cytochrome P450 isoenzymes in humans. Various isoenzymes. There are multiple isoenzymes in which we are going to see about only few of them. So the first one is cytochrome P1A2. So what does this mean? 1 refers to the family, A refers to the subfamily, and 2 refers to the members. The most important drugs metabolized by this cytochrome 1A2 is paracetamol and theophylline. It is way more important to remember these two drugs. First we saw A, now we're going to see B, particularly B6. So now B6 mostly starts with M. Remember BM. It is O mercaptopurine and methyl dopa. Remember as BM, bank manager. And then comes C9 and C19, which is cytochrome P2C9 and cytochrome P2C19. So when it comes to C9, it is phenytoin and vancomycin. And when it comes to C19, it is omeprazole and clopidogrel. It basically activates clopidogrel. Now these two undergo competitive inhibition, which one competes for the another one. Then comes cytochrome P2D6. D6, everything involves Remember, now for this D6, remember everything includes the letter P. Psychotic drugs which starts with P, opioids which has P in it, and all the beta blockers. Now remember that. And then comes cytochrome P2E1. Now E for ethanol. So we need to remember one very important thing in case of this cytochrome. This cytochrome P2E1 is particularly active when the liver is under stress or when there is any chronic alcohol consumption. In such states, this expression of cytochrome P2E1 increases, and its activity also can lead to enhanced production of NAPQ1, which is not needed for us, which is a byproduct or which is basically a product from paracetamol. So, in summary, the metabolism of paracetamol through cytochrome P2E1 can lead to formation of toxic metabolites, which causes hepatotoxicity. The next one is cytochrome P3A4, which metabolizes more than 50% of the drugs in our body. One important drug you need to remember is mifepristone, MIFEPRISTONE. Reduction. So what is reduction? Exactly, it is an opposite of oxidation, where you can do removal of oxygen and addition of hydrogen. The drugs which are primarily reduced are warfarin, halothane, and chloramphenicol. You can remember it as WHC. The next one is hydrolysis. So what do you mean by hydrolysis? It is nothing but the breakage or cleavage of the molecule or the compound or the substrate. So what is hydrolysis? Hydrolysis is nothing but breakage or cleavage in the compound by means of water. Mostly esters undergo hydrolysis. They can be esters react with water in the presence of esterase and gives alcohols and acids. Now coming to examples, we can remember as a mnemonic water can. Water will represent the term hydrolysis, and can will be similar to cane. So we can remember the examples as alkanes, procane, lidocaine, and procainamide. Next comes cyclization. As the name suggests, it's nothing but the conversion of straight chain compounds into cycles. Example, conversion of proguanyl, which is a straight chain compound, into cycloguanyl. Next we get into phase 2 reactions, which are synthetic reactions. These reactions undergo conjugation so that they are converted into water-soluble compounds, which will make them easily excretable. As we said earlier, it is GGAMS. First, we will look into glucuronide conjugation. Compounds which have OH and COOH are most likely to undergo glucuronide conjugations. So what are the drugs? Examples of such drugs are chloramphenicol, aspirin, and paracetamol. So when oral contraceptive pills containing estrogen and progesterone are conjugated, they become water soluble, which is easier for excretion. So where do we find this glucuronidase enzyme? It is present in our gut, that is in our intestine. So when we use any antibiotics like rifampin, this can disrupt this process by inhibiting this intestinal glucuronidase enzyme, which can reduce the reactivation of the oral contraceptive metabolites. So this disruption may lead to decreased effectiveness of the contraceptive, as the body fails to properly recycle and maintain the active hormonal levels. Now these antibiotics will interfere with the oral contraceptive pill's functions, because the main function of the oral contraceptive pill is to maintain the active hormonal levels. Now this disruption will lead to unintended pregnancies. Next comes acetylation. So what are the compounds which undergo acetylation? The compounds which contain amino and the hydrogen groups undergo acetylation using the enzyme acetyl coenzyme A. Example, sulfonamide containing the amino group and isoniazid which contains the hydrogen group. Next comes methylation. The compounds which contains amines and phenols undergo methylation. Example, methyl dopa and mercaptopurine. The enzyme used is methyl transferases. Next comes sulfonation. Phenolic and the steroid compounds are sulfated using SULT, which is sulfate transferases. The examples are methyl dopa and adrenal. Phase 2 reactions which involves conjugation can be classified based on whether they occur in microsomal or non-microsomal environments. It is purely based on the place where these reactions happen. The microsomal enzymes are located in the smooth endoplasmic reticulum of the liver cells. So the glucuronidation, which is catalyzed by the UDP glucuronidase transferase, which is the UGT, are found in the microsomal fractions of the liver cells. So the glucuronidation is basically a microsomal reaction in the phase 2 reactions. Whereas the other things, that is the sulfonation, methylation and everything, acetylation, all these happens in the non-microsomal cell compartments and the cytosol, which is why these are called as a non-microsomal phase 2 reactions. Now let's get into inhibition. So if there is a drug, we need enzymes which converts it into any other form of the drug. That is, it can be active to inactive or inactive to active. So whatever it may be, we need enzymes for that. So basic concept of the inhibition revolves around inhibiting the enzyme. The normal concept is that when you take a drug, it gets into the intestine and then it goes to the liver in its active form. There enzymes are present which will metabolize it and converts it into inactive form, which is excreted by the kidneys. So in case of inhibition, we take another drug which acts as the inhibitor. Now what this inhibitor will do is it will act on the enzyme which converts the drug into its inactive form in the liver. Now when this enzyme is inhibited, the active form of the drug is not getting metabolized into its inactive form. So this active form of the drug leads to toxicity because its concentration is increased in the plasma. Now, to understand the concept of inhibition more, we will get into one example about the HIV protease. As the name suggests, what does HIV protease do? It will destroy the proteins, that is the viral, the proteins of the virus, the RNA material or anything. It will destroy it and it will convert it into the inactive form. So basically HIV protease is a drug which you will take so that the HIV is basically protected. Now there is one small villain in our body, which is one enzyme called as CYP3A4. Now what this will do is this enzyme will act against the HIV protease. Now this will convert the HIV protease into inactive form. Now comes the concept of inhibition. Now we need something which is some inhibitor to inhibit this enzyme, that is the CYP3A4. So those inhibitors are the drugs, namely atazanavir and lopazanavir. This will inhibit the enzyme CYP3A4 so that HIV protease will do its job in an efficient manner by destroying the DNA material, that is the genetic material of the HIV. Now we will see about the hepatic extraction ratio. This is very important concept. Now what is hepatic extraction ratio? Now if you administer 100 milligrams of some drug, it will get into the liver, it will get metabolized. So the very first time it gets into the liver and gets metabolized, like if you give 100 milligram, only 50 milligram will come out and the 50 milligram is metabolized. Now this ratio is called as the hepatic extraction ratio, that is 50. Only 50 percentage, that is 50 milligram of the drug is metabolized. So the hepatic extraction ratio is 50. What is hepatic extraction ratio then? It is the amount of the drug that is metabolized in the first pass metabolism, that is as soon as it enters the liver. Now what about the drugs which have high hepatic extraction ratio? So it will easily get metabolized and it will be easily excreted. So when it comes to the drugs which have high hepatic extraction ratio, we need to reduce the blood flow. So why should we reduce the blood flow to those which have high hepatic extraction ratio? Because major amount of the drug is metabolized when it enters the liver. So we don't get enough amount of time for the drug to be active in our body. So we need to reduce the blood flow to the liver in case of such drug. So when we reduce the blood flow, we are able to retain much amount of the drug in the plasma concentration, that is in the blood levels, so that more amount of drug is not getting easily metabolized and leading to its inactivation and excretion. Next comes microsomal enzyme induction. So for example, some drugs like phenobarbital, these will act as inducers of certain enzymes, namely CYP3A and CYP2D6. What are these two enzymes? These two enzymes are responsible for metabolizing most of the drugs in our body. So if we induce these enzymes, metabolization will happen very fast in our body. That is, the metabolic rate will increase in our body by inducing these enzymes. So now who will induce these enzymes? Phenobarbital will induce this enzyme so that the rate of metabolism increases 2 to 4 fold times. So the metabolic rate will stay in peak for 4 to 14 days. Then it will return to its normal level in 1 or 2 weeks. So when you increase the inducer, the enzyme activity will increase so that the drug is metabolized faster, so that the plasma concentration in our body of the drug is decreased. Look into the consequences of the microsomal induction. So the consequences mostly include the duration of the drugs. So when some drugs are induced, it may lead to increase or decrease in the duration of the drug that is present in our body. For example, the OCPs. When we take antibiotics, it increases the metabolic rate of the OCPs, leading to reduced plasma concentration and potentially decrease the contraceptive efficacy. This is the efficacy. So the duration of the drug's action is shortened. In some drugs, they are activated by metabolism. So the duration and intensity of the drugs are increased. And when it comes to acute intermittent porphyria, there comes one small concept. Acute intermittent porphyria is characterized by the deficiency of porphobilinogen deaminase, that is PBG deaminase. So this will lead to the accumulation of ALA. So some induction of microsomal enzymes, particularly CYP450, can exacerbate AIP symptoms, especially barbiturates. These drugs induce ALA synthase, resulting in heightened toxicity and prolonged symptoms. It is crucial for the AIP patients to avoid enzyme-inducing medications. Some drugs induces its own metabolism, so there is no need of any separate inducer of these drugs.